Hello everyone. Here is how I love geometry. I'm Mr. Chao. This problem is from 2023 Aime1 problem number 5. Let P be a point on the circle circumscribing square ABCD. Circumscribed. So here is P. P is on the circumscribed circle. That satisfy PA. I just use low case letter A here times PC. So connect P and C, we got C. So equals 56, and the PB I use B times PD, here is D, PD equals 90. Find the area of ABCD. So this problem let us to find square ABCD. So we know we just need to find the length of this square. So here, this ABCD is a square. Then we easily to think about AC. So if we connect, and we know this is a right angle, APC, angle APC, right? Because AC, if we connect it, AC is what? This is the diameter of this circle, right? That's the center of this square, also the center of this circle. So this angle is 90 degrees. And we know in the right triangle, AC means the area, right? Means the area of what? The area of this triangle, right triangle, APC. It's 2 times of that. So we know AC equals this A times this A equals the segment AC times the height on this hypotenuse on AC. So we can say like H AC. So if we draw this one, it will be like this. This is right triangle, and we will got this one, right? So, and AC, we know AC is the square root of, let us suppose the triangle A, each side is S. So AC equals square root of 2 times S, right? S as square root of 2, square root of 2 of S. So now we know this equals AC equals square root of 2 of S times HAC. We know HAC equals AC over square root of 2 of S, right? Then the same thing for this right triangle. I mean for B and D, you see? Right triangle DPB. So this DB also the diameter of this circle. So this is also the right angle. And now we will got the height of this one on this, right? Why we got this? Because we can easily to find this is the center of this circle if we connect. Now this one is an rectangle, right? It's very useful. P to this point and to the center of the and this point. This is a rectangle. Here is right angle, and this is a rectangle. And if I, let us say here is O, let us connect OP, and this is also what? Also the radius of this circle, and also you can say square root of 2 over 2, right? Then S. So PO equals this one, because the diameter is this. So this is just half OP. So half of square root of 2 of s. So that's the main idea of this, why we want to find HSE. And also we can write like H, here is SE and dB. HdB will be, this is AC, so here it must dB square root of 2 of s. Okay, and we know this squared plus this squared, right? This squared plus this squared then equals which one? Right, this one square. Now we will get, because AC is 50, we can substitute. AC is 56 over, now is 2s squared plus dB is 90, so 90 s is squared and squared, and 2s squared equals 1/2 s squared. Okay, so let us use t equals s squared, and each side times 2s squared. So each side times 2s squared. We will get 56 squared plus 90 squared, and this will equals 1/2 times s squared times 2s squared, right? We just times each side times this one, so 1/2 and 2, so that will be t squared. We just use t equals, so we will get 56 plus 96, 50 plus 6 squared plus 36 plus 600, right? So that's 3136 plus and 81 and that's t squared. So how much for that? 63211, so 11,236 equals t squared. So now we can guess this one, because 100 squared equals 10,000, right? And 110,000, right? So it must be between this one. T must be between 100 and 110. And we know this is 6. So it only can be 106 or 104. So we can try like this, because the last two number is 36. So it looks like 106 times 106. Let's check. So that's it, right? Yes, that's, so we know t equals 106. T equals s squared. S squared is the area of ABCD. Done. We find the answer of this. We find the final answer. Now, sometimes sometimes one geometry problem have a lot of different ways to solve it. And here, it's obviously we can use another way, because this we can use, which one? We can use Ptolemy's theorem, and I will draw it this square once more. Right? So here is P, PA, PB, PC, PD. here is A, here is P, B, C, D, A, B, C, D, and here is A, B, C, D. So we can draw this one as the same. That's the first V1 as V1, right? And we can got if we connect DB, and we also know A, and we know it's given AC equals 56 and BD equals B times D is 90. And we also know A squared plus C squared. A squared plus C squared. I mean, this, we know this is a right triangle. So, right, this A squared plus C squared equals AC squared, right? AC squared is 2S squared. And also B squared plus D squared also equals DB squared. They are the same, 2S squared. So they are A squared plus C squared equals B squared plus D squared. Only this equation we can solve S, right? We want to find S. So here we know the Ptolemy theorem. First we cancel like here, this one, this cyclic quadrilateral, right? Cyclic quadrilateral. And so A times S plus, here is C times S equals diagonals. This is D times this is D. This is D times square root D times square root of 2. This is D, and AC is the square root of 2 of S. So, and we can cancel the S, and we will got A plus C equals square root of 2 times D. Now, we know this one, and this one we can use, because this A plus C we can square out, and then square root of 2 of D, then squared. We will got which one? A squared plus C squared plus 2AC equals 2D squared. And we know this is given A squared plus C squared. We can use, because here is D, so we can use this one. They are the same, right? So we can use B squared plus D squared to substitute this A squared plus C squared plus 2 times, here is 56 equals 2D squared. And now 2D squared just minus 1D squared. And we will got which one? So, and we will got which one? D squared, right? B squared equals D squared minus 112, right? And we know, and we also know this one, B times D, we can use B times D. B here, B times D is 90. Then we can use B equals 90 over D to substitute, right? We can use D squared, and so BD equals 90, then B equals 90 over D. So B squared, it will be 81,090 over D squared equals D squared minus 112. And let's use t to substitute d squared, okay, d squared, then it will becomes which one? A0 t over t minus 1 1 2. So each side times t, then we will get t squared minus 1 1 2 t minus 0. That's wave 0, right? Each side times t, t squared minus 1 1 2 t minus 8 1 0 0. Now we just to solve this equation, then t equals 2a squared minus 4, then plus 4 times a100, and if we try this one to get the calculation, then we will find what will be d. So d squared, so t will be 162. Yeah, I just omitted the whole process for calculation, and I have limited space for this one. So we will got b squared equals this d squared minus 1 1 2 d squared. So this is t is d squared. So it's t minus 1 1 2. So 162 minus 1 1 2. So we got how much? 50, right? B squared. Now we got b squared and b squared and d squared, and put them together, that will 2s squared. So 2s squared, we will got s squared equals 50 plus 162 over 2. That's how much? That's 211. 202 over 2, so it's 1 over 6, right? Yes, done. We got the same answer. Of course, it will be the same. Yeah, now, in summary for this problem, I used 2 different ways to solve it. And the second way got a more complicated calculation. And the first way is much more smarter, I think, and will makes the problem simple because it uses the height of hypotenuse, and also then find these two heights relationship with the side of this square, or you can say the radius of this circle. Then we can easily to solve this equation. But second way 2, right? We can say way 2 also we use Ptolemy theorem and the Pythagorean theorem, and to solve the equation. Yeah, got more calculation. But it also works. I hope you enjoy it. Thank you.